All right, we've talked about ionic and covalent bonds. Now we're going to talk about metallic and polyatomic bonds. So let's go ahead and get started. Now, the only thing you need to know about metallic bonds is what they are and their definition. And these are a bond between two or more metals. And the picture represented below just shows you kind of what it looks like, because it usually looks like positive charges of the metals in a sea of electrons, and they just kind of bond like that. But again, you don't need to know how to make a metallic bond, you just need to know what a metallic bond is. Now, let's look at polyatomic ions. We've talked about compounds that have either ionic or covalent bonds, but now we're going to talk about some that have both ionic and covalent. When two nonmetals combine in a covalent bond, and they don't fulfill the octet rule, then they also end up creating an ion that has two or more elements in it. And this is called a polyatomic ion. And so the official definition for polyatomic ion is an ion made of two or more atoms or elements. Now, there are many common polyatomic ions, and sometimes you'll see a parentheses to group the atoms together. So whenever you see parentheses, you know for sure you have a polyatomic ion. So let's practice. All right, now this is the polyatomic ion chart that you should see in your notes. And just a reminder, like when we have a compound, let's say like NaCl, sodium chloride, the difference between it and a polyatomic ion, they both have two elements, but the difference is the polyatomic ion has a charge right here, a plus charge. When you have a compound come together, it should be neutral charge. You should never have a charge. So when you still have a charge, that means you have a polyatomic ion. So let's practice a little bit. If I have, let's see, if I have magnesium with a 2+, and let's see, NO3 negative, nitrate, I have nitrate. These two can make a compound, and you can do the crisscross again, just like you would do with ionic bonds, except this is a polyatomic bond. And then you would just say Mg, and there's going to be a 1 here because there's a -1 up here, so we don't even place it. But since we're going to have two NO3s, really it should look like this. But we don't write compounds like this because this is going to tell us we have two of these. So the way that we actually write it will be magnesium nitrate to show that they have two of them. Now, when you have a parentheses like this, that means that you know for sure you have a polyatomic ion. So that shows you right there where the polyatomic ion is. Sometimes, though, you won't have the parentheses, so let's do an example of that. If we have lithium, which has a 1+ charge, and you have cyanide, which has a 1- charge, then when you write them together, they're going to look like this, okay, with no parentheses. However, the way you know if something's a polyatomic ion or not is if it has 3 capital letters. If it has 3 capital letters, then that means you have 3 elements. So therefore, you have to have a polyatomic ion instead of an ionic or covalent bond. This tells you that you have a polyatomic bond. All right, now I want you to pause the video, and I want you to do the practice problems that you have listed in your notes, and we will come back and look at the answers. Okay, let's look at these answers very quickly. For number 1, we have hydroxide being used, and it's right here, and it's hydroxide. Okay. The second one, if you'll notice on your chart up there, SO4 is sulfate. Okay. On number 3, you have parentheses on this one also, so that helps, and it's chlorate. All right. In number 4, you have chlorate again. It's right here. It's just not in parentheses because one was not needed. In number 5, you have cyanide, like we did in our example. Number 6, it's at the beginning because it's a positive polyatomic ion, which is ammonium. Number 7, you actually have oxalate. And let's see, the parentheses around this one, so that makes that one a little bit easier. And so this one is nitrate. And then the last one is sulfate again. If you have questions about these, make sure that you write them down so we can talk about them in class tomorrow. And very quickly, I would like you to pause the video and write if 1, 2, or 3 are ionic, covalent, or polyatomic compounds. All right, guys, let's check our answers. For BES, that is ionic. CO2 is covalent. K2SO4 is polyatomic. So hopefully you got those right. Again, if you didn't, jot down some questions so that you can ask me tomorrow in class. All right, now we need to talk about 2 types of formulas. We have molecular formulas and empirical formulas. Molecular formulas are those formulas that show the number and kinds of atoms in a molecule, but it doesn't show the arrangement of atoms, okay? So the molecular formula for a compound is always unique. 2 compounds will never have the same molecular formula. Make sure you remember that. Now, an empirical formula tells us the smallest whole number ratio of atoms that are in a compound. It basically simplifies the molecular formula into a more simplified form. Empirical formulas are the formulas in the most simplest form, which we just talked about. And you can find the empirical formula by simplifying the molecular formula. And real quick, empirical formulas, you actually can have the same one for different compounds because they're simplified versions. Now, let's look at an example. Butane. Which one of these is the molecular formula and which one is the empirical formula? Pause the tape and make your decision. All right, C4H10 is the molecular formula. Okay, it's this one. C2H5 is the more simplified version, so it's the empirical formula. Now, let's look at para-dichlorobenzene. Which one of these is the molecular formula and which one is the empirical? Go ahead and pause the video and think about it for a minute. All right, C3H2Cl is the empirical formula because it's the simplified version of the bottom C6H4Cl2. The bottom one here is the molecular formula. The first one is the empirical formula. And like I said earlier, 2 compounds can have the same empirical formulas because they're just in a simplified form. Okay, now I need you to summarize this video. And what I would like you to do is I would like you to do a tweet summary where you tweet in 140 characters or less what this video, the main point of this video. I hope you have a great evening and I'll see you in class.